Hi, everyone. I'm Jeff Silverman, former astrophysicist here in San Francisco, California, and I'm joined by Dr. Rachael Livermore out in Melbourne, Australia.
And we have a very special guest with us today, who I'm very excited about because she works in my field of gravitational lensing. Please welcome Dr. Anahita Alavi.
Hi, thank you, Rachel. I'm Anahita. I'm here at Pasadena drinking milk as a mommy. And then I'm very excited about this program.
So you work on gravitational lensing, as I said. So can you tell us a little bit about what gravitational lensing is and why it's interesting?
Okay, so the gravitational lensing is actually a natural phenomena which for the first time was actually predicted by Einstein from his theory of general relativity. The basic idea behind this effect is that a massive object, for example, a galaxy, the gravitational potential from the massive object can change the path of the light rays and can focus the light. And because of that, the image that we see from a galaxy, which is very far away from us, can be much brighter and larger.
So it's essentially like having a gigantic natural telescope out there in space.
Yes, exactly. So it's like looking at distant galaxies using two telescopes. One is the telescope that we already have, either on the ground or in the space, for example, Hubble Space Telescope, plus basically combining with what the nature gives us as a natural telescope.
So any distant object that gives off light can be lensed, gravitationally lensed, by some big clump of mass between us and that object. So what specifically are you studying that gets brighter and bigger using these gravitational lensing?
So astronomers always have this concern that when we are looking at very far distances, the only thing that we see is the bright big galaxies because it's easy to see them. But the question is that what about the faint small galaxies? Do they exist? If they exist, how should we see them? Because these galaxies are much fainter beyond the detection limits of the best telescopes that we have today. Even Hubble cannot see these galaxies because they are very faint. But now that we know about this lensing effect, we can actually use this gift from nature in order to see these distant, faint, small galaxies. The galaxies that I'm talking about are a few hundred times smaller and fainter than our own Milky Way. So you can just imagine how it's hard to see these galaxies. But when we use this effect, we actually can see these galaxies because this effect, as I said, magnifies the light coming from the background distant system. So as a result, we can see them.
So studying the faintest, farthest away, smallest galaxies sounds really hard. It's definitely not easy, that's for sure. So how'd you get into this, niche part of astronomy that's, sounds simple, but is one of the hardest things, right? You're looking for the smallest, faintest things out there.
Yeah, so the thing is that I actually started to work on this in the second year of my PhD, where when I started to work with my advisor, there were many different projects. But then this project of looking for something that we know exists but haven't been detected ever. So it's very interesting because I was like, oh, I might be the first person to find this galaxy and see these galaxies like this, which was very exciting for me. And other than that, this project basically, because in this project we use the data from Hubble, and that also seems very interesting, I guess, for everyone. Because of very pretty images by Hubble. So it was basically combining this idea behind a very famous theory from Einstein using this gravitational lensing and combining it with the best data that we have today. It's from the data from images from Hubble. So combining these two big things was very exciting for me. So that's why I decided, okay, I want to work on this project, which at the end, it was successful, and we could find actually a large sample of these very faint galaxies at very large distances.
And where do you see this field going next, particularly with the launch of, say, the James Webb Space Telescope next year?
I think these days are like golden ages for astronomy in general, but especially for this subject of looking for very distant faint galaxies. The next generation of telescopes, for example, the JWST, which is a space telescope launching sometime in 2019, hopefully, and then the ground-based telescopes, for example, the new ground-based telescopes, for example, the 30-meter telescope. The faint objects would be the primary sources, the primary targets for these next generation telescopes. I guess it would be very exciting to work in this field and in this subject because, for example, with JWST, which is a telescope much larger than what we have from Hubble now. So it actually enables us to find even fainter galaxies at even further away distances than what we see today with Hubble. So I'm really looking forward for those data.
Yeah, I'm obviously super excited for JWST as well, and I'm sure we're going to be working on the same things and hopefully not competing too much. So thanks so much for talking to us today, Anahita.
Thank you.